Welcome back. This lesson we're looking at tangents and normals. So to start off, let's look at the graph of a cubic function. So this cubic function here, you can see the blue graph. If we've derived it, we're trying to find the gradient of the tangent at any given point. So let's look at the point x equals -1. If we were to look at the graph of the tangent, we can see here at -1 is where those two graphs touch and they have the same gradient at that point. And if we play that through, we can look at the tangent as it moves along that whole cubic function from left to right and then bounces back around. So we can see here the red line has positive gradient, negative gradient, and then positive gradient. At the turning points, you can see we'll get to a horizontal line. So the gradients will be at 0 as we get to that point. If we were to sketch the derivative, we can see we get a parabola, and between these points here, we see it is positive. We go through playing it. As we get to those turning points, we can see the turning point here is where the same x value is where it turns around. So from the left, we can see the gradient is positive, 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 looking at the green line. And when it gets to -1.309, that's when it is at 0. And then between that point, those two turning points of our original cubic function, we can see that the green graph here is negative, and then after that it is positive. Now we've done those two graphing things before, but we haven't really sketched the tangent. So as we play that through, we can see what's actually been represented here is that red line is the tangent at a given point. So where they intersect here, they share a gradient. As we play it through, we can see how we get that parabolic shape. So for this exercise, we're going to be looking at how do we actually find the gradient and the equation of the tangent line and also a normal. So let's look at a more simplistic example. If I was to give you the equation or a function f of x equals x squared, nice easy parabola, we'd say, well, to find the tangent, or find the tangent at the point 2, 4. Alright, so let's pretend that's our question. First thing we have to do is, well, we know the tangent, no matter what it is, no matter what graph we start with, the tangent is going to be a straight line. It's going to be a linear equation. So we know we want y equals mx plus c, and that means we want to find a gradient and also an intercept. So the first thing we can do is let's find m, and we know the gradient is found by finding the derivative. So m is going to equal the derivative of f at whatever point we started or we want to find. So at the point 2. So let's find the derivative of f of x. So f dash x would be 2x, and then substitute in x is 2 because that was given to us in the original equation up here. So therefore the gradient is 4. From there we can use our linear equations to solve. We have 1 point and a gradient. So we could use y minus y1 equals m outside of x minus x1, or if you want to, you could use the y equals mx plus c, just an extra step involved there. So let's use the first one. Y minus, we know the point 2, 4, so y value here is 4, m is also 4, as we found over here in our gradient, x minus 2. So then when we simplify this out, or expand our brackets, 4x minus 8 equals y minus 4, so we plus 4 to both sides. We get y equals 4x minus 4 will be the gradient of the tangent. So let's have a look again at Desmos, and we can sketch those two. So let's put in a new graph, and at x squared, we want to find at the point 2, 4, wasn't it? So at 2, 4, we can see that now our blue line here, 4x minus 4, you can see makes a tangent at that point. The second part of this exercise is to find what's called a normal. So there's our tangent line. So the tangent to f of x at 2, 4 is equal to this equation here. Okay, now the other type of line you can look for is a normal. Now a normal is when the line meets that original point at a right angle, or it is perpendicular to that point. So if we were to have a cubic function like this, so there's my axes, at this point here, we'd say the tangent, that's terrible, so the tangent goes like that, share a gradient, so that's our tangent. At that same point there, where it crosses at a right angle, we call our normal. So the process is pretty much the same, except the one thing we have to remember is if two lines intersect at a right angle or a perpendicular, the two gradients of the two lines will multiply to make -1. So we know that the gradient of the tangent is the derivative. So we can say that the gradient of the normal would be equal to -1 over the derivative at a given point. So m1 is our derivative at that point. So then the gradient of the normal is just the negative reciprocal. So let's do that same question. So f of x was equal to x squared, and we want the normal at 2, 4. We'd find the derivative first. So the derivative we found was 2x, sub in the point that we know, which is 2. So we know it is 4, so therefore the gradient is equal to -1 over 4, or -1/4. So that's the key difference. The rest of it, working out, process is the same. So you can start with your linear equations, y equals, now I'll do the other way just because I've done the top equation first. So if you want to use mx plus c instead, like I said, there's an extra step, but some people prefer just to remember the one formula. We know the gradient is -1/4. We know the point 2, 4 from the first equation, or the first question. So let's substitute in 4 for y and 2 for x to find c. So -1/4 times 2 would be -1/2 plus c equals 4. So therefore c is going to equal 4.5. So when it comes to writing our final equation, therefore the equation of the normal is y equals -1/4 x plus 4.5. And let's check that on Desmos just to see if it looks like it's a right angle. So we change this one to -1/4 times x, and then we're going to go 4.5. Oops, that should be a plus. And we can see here at that point, 2, 4, might even put in the original one. We can see that they cross at a right angle now. So that blue line is now our normal equation. So just to quickly recap, your tangent is the straight line that shares the gradient at any given point along your original function. So first find your derivative, sub in your known x value, and that'll tell you your gradient of your tangent line, and then just use your linear equations to solve with the gradient at a given point. For your normal, the extra step is to remember that it crosses at a right angle, it's perpendicular, so once you've found your derivative, subbed in your x value, you then take the negative reciprocal of it. So if it's positive, change it to a negative and flip the fraction for those who are looking for a shortcut. The rest of the steps, use your linear equations. You can use y minus y1 equals m outside of x minus x1, or you can use y equals mx plus c. You should get the same answer if you've done the above steps correctly. All the best for finding the tangents and the normals.